So where we are creating fact table, right? So fact sales ID is primarily for the fact table and customer ID. So hint we need to take some difference. So from where we are taking differences. So in dim customer, so in brackets we need to mention customer ID. So there we have in the dim customer we have customer ID. So check it dim customer. So this is the primary key we are taking. Okay. So like that again product ID in references. Okay, dim product and inside we have product ID. So this one we are taking product ID. Okay. So again we have date ID references dim date ID. So date table we are taking. Okay. So this is dimension primary. Okay. So again store ID references dim store ID. So from dim store we are taking. So then again we have quantity and total amount. So we have taken difference from the dimension tables, not from the subdimension tables. Subdimension tables, dim region, dim category. We are not taking reference. Why we are not taking means, so these are these dim region. Okay, so region ID. So this table referring we have in this dim customer, right? Region ID. Okay, that's why no need to take in the fact table. Again, this category ID primary key we are already have in the dim product table. So here we have so difference. Okay, so that's why we are not taking these also. Okay, we are not taking region and category. So we know that we need to mention only dimension tables. So these dimension table going to mention those are in the subdimension tables. Okay, this one region ID category. Okay, this in the tick. Then we have quantity total amount. Okay, then we going to insert some data. So are we going? So I'm selecting every data. Okay. Data. Table amount created. We're going to recreate it. Database schema. Table. Then inserting data. Okay. Now check data. This table. So what type of data we have? So dim region. So we have uh, region ID, region name like this is region code. Okay. And then in category table, so we have dim category. So we have this data category ID, category name. Okay. So 100 and electronics. And again, dim customer. Those are subdimension tables, right? Dim region, dim category. Okay, here we have dim customer. We have like a dim customer. So dim customer inside we have data. See, customer ID and name. Okay, as job snake and gender region ID we have this. Again, check data in the dim product. Region ID from sometimes table region. Yeah. So dim product. Okay. So product ID, product name, category ID. brand we have in product table. So again we have team date. Team date what we have. So in team date we have store ID, store name, we have the date. Okay. Then again take it the dim store. Okay. Dim store. So then so on the store ID, what is store ID, what is store name, city and state. State. And again we have fact table, fact page, select store club. So this concept is important for who having the inside. So they will ask in interview, have you done data modeling? Okay. What are the schema? Schemas అన్నప్పుడు స్టార్ schema, Snowflake schema. And schemas అన్నప్పుడు table schemas, sorry, database schemas, information schema, public schema by default we have. So remaining schemas we're going to create. By default, include schema, public schema. So we have when we creating the database. Okay. So this is the fact sales. Sales ID, customer ID, product ID, date ID, store ID, quantity. See, sales ID is into the fact sales table, and these are dimension tables. Customer ID, product ID, date ID, store ID, and quantity and total amount fact sales table. So now what I need to find from these tables. Okay, what is my requirement? Requirement is okay. So we have different regions and different categories. Okay, I need some region wise. So what is the category in that? I need total quantity and what is the sum of total amount of sales. Okay, I need to find this one. Okay, so region wise, I need to find total sales and total quantity by the category wise also. So I need four region wise. I need okay, and category name I need that. Okay, so this region and category wise, I need total quantity, and after that, what is the total amount for that? I need to find for that. So we try the this query. So select uh, region name and these are remember always alias names. Okay, so region name, category name, and sum of every quantity as a total quantity. Sum of total amount as a total sales. Okay, we are using these functions. Some which function aggregate or identical function. Sum is aggregate function. Okay, so then from fact sales. Okay. So region category names. Okay, and these are from the fact sales. I'm using fact sales F. So Jane dim region on customer ID if fact table customer ID customer customer ID again join dim region and here region ID from the customer table region ID and region table and dim product we have from the fact table and the product table product ID from the fact table product ID. Again dim category, okay, join dim category table. Okay, here we have one category ID from product table and this is subdimension table. This is subdimension table. So region ID, this is subdimension, this is subdimension table. That's why we are giving uh, dimension, not fact table. Here also we given dimension table, not fact table. Okay, so again category. So here I'm using the group by class. Group by class why I'm using? I mean I need these total sales and quantity region wise. So there's a group by region name and the category name. Then I need in the order with the region name and category. Okay, this is the file. What we going to get? So from the region wise and category wise, what is the total quantity, sales, I mean, and what is the total amount for that total quantity. So this is going from this structure. Now let's check. Okay, so region name in each region, the category of electronics. So total quantity sales one quantity and total sales price so $200. So again in region the region of west region, the category name of electronics. So total got two sales and here we have $1,500 for this total sales amount in this region. Okay, so we need to find like that in region we have so different. Suppose I want to laptop. I want to buy laptop. So laptop stores we have in Hyderabad. Also we have in Bangalore. Okay, and also we have some districts. Okay, state wise and in India, in different states we have and well, in different countries there are different cities. Okay, so we have everywhere, and we need to check from in which city the sales high and we need to buy and which product. Okay, in which city in which sales is high like product name or laptop or mobile and so what type of they are preferring to use, so like that we need to find. So real time then only next time if they are going to introduce any new brand, then they will get one idea that product how they need to rebuild the product. Okay, that purpose only we're working. Okay, their client we are giving the data to us to find out next what we need to do. So we have millions of rows in the real time. Okay, so this is about okay fact. Finally, we are finally so region wise and categories, the product quality and the total sales. Okay, so here I'm showing this one. So schema we know and somewhat I will also do some OLTP overlap. Okay. So we also have OLTP system, right? OLTP systems and we have OLAP. Okay. Snowflake is OLAP and suppose so Oracle these are other things Oracle SQL Server those are OLTP system on premises were OLTP. So suppose banking I go to bank, so I will deposit the money, I will withdraw the money, I will check the balance. I do some transactions every day. So those transactions, like it's a daily update. So those going to handle by the poetic systems, transaction based. So OLAP. So after doing the transactions, after 1 year, 1 year after doing the transactions, so we had the OLAP system. But after the 1 year, I need to analyze the what I have the transactions. Okay, when I have my total amount of deposit, total loss, when and which date, like that we need to analyze the data. For that analytic purpose, we're going to use the OLAP. Okay, OLAP. So OLAP is online transaction processing. Okay, and OLAP is online analytical processing. We are using. Okay, here it is like e-commerce orders. Okay, ATM methods we're going to use the so OLTP. So highly here we're going to use so small and physical transaction. So every day happen right like so highly normalization tables we're going to use here. Highly normalization. Highly normalization tables we're going to use in this one. Highly normalization. So here normalization. Normalized tables we're going to use in the OLTP system. So then here we're going to detections we're going to avoid from this one and fast and insert update and design for applications only. So OLAP here going to be like so used for analysis and reporting. Example like data warehouse, BI dashboards, trend analysis like that. Calculation like so read heavy queries we're going to handle heavy queries and then aggregations, totals, trends. So multiple we can generate multiple dimensions. This is for only analytics OLAP. Okay. So this one. So already I told about you fact contents like memory data or quantity data. So sales amount, quantity, profit, revenue. This okay, in dimension like tables would have like customer details or product information, data to store details like that. Okay, this one. So data modeling is two types. One is in warehouse can use star schema, Snowflake schema. So store schema is a data warehouse design where the central is a fact table links direct to the multiple dimensions. Okay, so again here we're going to use fewer chains only in star schema, and in Snowflake schema we're going to use multiple chains. Okay, so advantage of this schema, okay, star schema. So for simpler model for using for business users who are going to use, okay, those are advantage. Okay, so Snowflake is like a normalized version Okay. That is normal version of a star schema where dimensions are split into sub-dimension tables. Inside we have also sub-dimension tables. So advantage for savage storage, handles complex identities. The disadvantage, slower queries due to jails. If you have multiple jails, it's going to run slowly. This is okay. And we have normalization, denormalization, right? So they will ask, these are modeling concepts. Okay, so we can tell like out of Snowflake develops syllabus. So, but we need to know everything. So, not sure. So this is like we need to splitting. Nano is nothing but we are splitting okay, data into multiple tables. Multiple okay, multiple related tables. So this is the normalization. Multiple related tables we go into splitting. Multiple days. Okay. So here, most of the time we're going to use on the user in OLT position. Further, we're going to use normalization and the Snowflake schema. Okay. So it's going to save the storage. Okay. Uh, it's going to data integrity we can maintain. Okay. So we can apply the more chains, but it's going to run slow queries. So this is the normalization. So then we have denormalization. So denormalization. What is here? So navigation, we are splitting data into multiple related tables. Renormalization. So, so this is used for only so OLAP systems. So OLAP means warehouse only. OLAP systems and store schema. Approach star schema and both Snowflake approach normalization, denormalization. But this star schema approach only denormalization. Okay, approach. So here what is happening? We can fast query performance. So simple data model and return data more storage required. It's going to take the more storage, denormalization. And here splitting the data into multiple tables, but here simple combining the attributes and combining the columns to the fewer tables only for simplicity. Okay. For the fewer tables only we're going to. So here we have multiple tables. So we are splitting same data in multiple tables, but here we are uh, using only fewer tables, combining the attributes means combining the columns. This is okay. So what you need to know what is the star schema and what is the Snowflake schema. So what is the difference between star schema and Snowflake schema, and what is the OLTP and what is the OLAP? What is the difference between OLAP and OLAP? Okay, and then what is the normalization and what is the normalization? What is the difference between both? Okay. Then what is the fact table and dimension tables? What type of data stored in the fact tables? So what type of data stored in the dimension tables? Okay. And in start we have fact and dimension tables in Snowflake schema, fact, dimension tables and sub dimension tables. Okay. So as for the requirement we're going to use the this one. So this concept is like a data modeling concept. Okay. So they will ask you, okay, which schema you are in your using project means we need to go with Snowflake schema. Only. Have you create, have you designed modeling? They will ask. So if you have like 3 to 4 years experience, no need to say yes. Okay. If you have more experience, okay, then you need to tell yes I done in one scenario only, not every time, but one scenario. So I created I done modeling. So they will give any scenario. Suppose this gives some tell retail project or a bank or anything. So are you going to create? What are the tables you're going to create and what are the attributes? Attributes means columns. What are the attributes you're going to give in each table? So they will ask. Okay. So rarely it's happened only 2 times, not every time. Generally they will ask different. They won't ask to design practically. So have knowledge of this one. But if you don't want to go, just say I have not created. I have not get to chance to create. Can tell like that. Okay, clear. So as of now, we need to regarding the session. Start Snowflake schema. So okay, we will be Connect tomorrow 10 a.m. Okay. I will share. Okay. We will connect tomorrow. Bye.